Okay or not? Yeah, I have to check the marks. Actually, compare means what? Comparing with last examinations, little bit okay, 40s. I didn't arrange board also. What? But today I will try to give maximum portion notes some thermal properties of solid mechanical properties of solids. We have to read also formulas one maximum formula based on this one. Okay, just means force where we are applying that one only very easy thing. Actually, easily we'll get the marks. So please, hello, Chip Sanju. Hello, Babu. Hello, Amma. Kanishka, చెప్తాలి సో చిచి Kanishka, please tell me తల్లి. Questions, huh? Okay. Okay. Okay, Dali. Just wait. This time, little bit means we are going to plan. Means I will discuss with the people and I will do it. Okay, na? No problem. Okay. Like that. Okay, your Vishwam means Vishwan is comfort for the people. That only we will do. The reason is you people also knows. You people also experienced only with these all things. That's why. Okay. Fine, please. Questions we will do. First of all, let me write the formulas. Okay. People have to read. Compulsory. People have to read. Then only now, without seeing, people have to apply those all things. Okay, that's why I will give means some formulas. Then you have to read. Then I will give the questions and I will make to solve. Okay, so concept means explanation. I will little bit. I will decrease it, but one thing important points only I will. Mechanical properties of solids. Mechanical properties of actually, here, rigid body. What is that? Rigid body means what? Rigid body means what people have to know. Whatever maybe the please listen fastly. Are Ramya and Subleka, please. Okay, rigid body means whatever may be the body you can take a mom, whose shape and size does not change even apply the force, external force. Means the distance between the particles inside the body is constant even we are applied force. Okay, that is means no change in shape, not deforming, nothing will happen. Okay, we are applying even though. So rigid body, right up, first point, rigid body. That one was just people have to know what is this, that's it. One minute, Amma, 1 minute. 1 minute. Rigid body. A body whose shape and size, whose shape and size can't be changed. Can't be changed. However, large the applied force may be. Once again, shall I read? A body whose shape and size can't be changed. However, large the applied force may be is called rigid body. Amma. Okay. Actually, next line. There is no perfectly rigid body in nature. There is no perfectly rigid body in nature. Next, deforming force. Deformation force. Deformation force. A force which changes the ma'am, please chapandi. A force which changes the size or shape or both of a body. A force which changes the size or shape or both of a body without moving it as a whole. Okay. Next, restoring what? Just shall I repeat again? A force which changes the size and shape or both of a body without moving it as a whole. Array, not HOLE, WHOLE means complete body. Means it not means the body will not distribute, means we are not applying all the body, just at a single point we are applying, means it going to be what? Distribute. Yeah, fine. As a whole is called what? Deformation force. Next, restoring force. Restoring force. The force which restores the size and shape of the body. The force which restores the size and shape of the body when deformation force deformation force, when deformation forces are removed, is called restoring force. Is called restoring force. Put star mark and write down. Deformation force and restoring force are action and reaction pair. Deformation force and restoring forces are not deformation. Wait, deformation force and restoring force are not action. Why? Because deforming force and restoring force are acting in same body, amma. Action reaction forces are not on the same body. Okay, action will be act on A means A will be act on other body. Okay, see, suppose I am pushing, okay, surface. I kept the block on surface. Weight of the block acts on surface. Surface, due to surface, normal force acts on block. So if it is action means this is what reaction force. But deforming and restoring force are acting the same body only. Why? Because we are applying means we are removing the deforming force on the same body. Due to restoring forces, it will be regain its original shape and size. Okay, that's why please write down. They are not, what is that? Sorry, deformation force and restoring forces are not action and reaction force. Not action and reaction pair. Forces are pairs. That's simple. Next, elasticity. Elasticity. The elasticity, right? Sorry. Actually, mechanical properties of solid, the other name of this topic is, okay, elasticity is nothing but what? Mechanical properties of solids. Okay, fine. Elasticity. A body. Elasticity is the property na. Sorry, please. The property, please. The property of a body. Actually, elasticity is the property of the body. Elasticity, just the property of a body by virtue of the property of a body by virtue of which it regains its original size and shape. When deformation forces are removed. Once again, the property of a body by virtue of which it regains its original size and shape when deformation forces are removed. Is called elasticity. So elasticity is nothing but what? It is the property of the solids. Okay, na? Materials means what? Suppose top, otherwise what? Some rubber. People otherwise have hair band, what we have to call hair band. Something will call na. Generally girls. Okay. Then just please expand and leave it. Then again it will come back. Spring, just compress and leave it. After means just after leaving, what is that? Again it come back to same original position. that nature is nothing but elastic nature. Okay, now. So fine. Next, elastic body. Next, elasticity. After that, what? It is the property. It is the property of material. That's it. Next, elastic body. Elastic body. Write down. A body which shows elastic behavior. A body which shows elastic behavior is called elastic body. Example, rubber, steel, these all are. Actually, generally means quartz is the near to perfect elastic body. Very close, but not perfect. Means nearest approach to perfectly elastic body. Quartz. Quartz. Put star we can write down. Means maybe in that bits they may ask, that's why. Quartz. Nearest perfect, nearest approach to perfectly elastic body. Perfectly elastic body. Please write. What? Nearest approach to perfectly elastic body. Man, no body is there. Perfect means okay. Very nearest. That will you find. Next, plastic body. Plastic body. Plastic body. A body which does not show elastic behavior. A body which does not shows, a body which does not shows elastic behavior. Which does not shows elastic behavior means, see, in previous, elasticity is the property of body. That property does not obeys for this body some. So what we have to write? A body which does not shows elastic behavior is called plastic body. Nothing but what? See, for the ceilings putties we will keep that putty for houses we will keep putty. That putty. Next, what is that? Wax, bubble gum, other chewing gum. These all are what? These all are nothing but what? Plastic bodies. Okay. Actually, steel is the more elastic. Steel have what? More elastic nature than rubber. Please, over this one. Chewing gum also, if people want to write means you can write them. Otherwise, okay, chewing gum. Okay, next point. Steel is the steel have more elastic nature than rubber. Steel has more elastic nature than rubber. Means generally people will think what? Rubber have more elastic nature. No, steel only. Steel have what? More elastic nature than rubber. Okay, Amma. Next. Amma. Now we enter into the topic now. Stress, so strain, language, something we are going to read, Amma. Please, fatafat, you people have to now only try to read the formulas also, okay? When we knows the formulas means maximum it's going to be complete, Amma. Very fastly we try to. Amma, steel, elastic nature is greater than what? Rubber. Okay, now we wrote or not? We wrote or not? Okay, fine. We wrote means very good. Fine. Okay. Next. I'm going to arrange some result. Fine. Next. Now, stress, strain means in this, what is that? Stress and strain in elastic material we are going to read. So for that first property, okay. Stress, right? Stress. Please, very important. Here onwards only. How to calculate stress, how to calculate strain, okay, what is the cross sectional area, what is the difference between stress and pressure, okay, these are all things we have to see. Means different types of stresses, these all things, okay. Stress, the restoring force, developed per unit area of the deformed body is called stress. Stress is equals to restoring force divided by area of cross section area of cross section area of cross section. Area of cross section. So simply restoring force F by A. Okay. SI unit is what? Newton per meter square. Newton per meter square. F is nothing but what, Amma? Actually, this restore, Amma, listen once. Something is there, Amma. Just suppose I applied some external force. Okay. What will happen? It automatically, little bit, it is going to be compressed. Up to here, this much of height is decreases. Then applied. At that time, after up means suppose little bit, this much of height only it compressed. After that, it is not compressing. The reason is their internal forces are going to be developed, Amma. At that time, external force is equals to internal forces. Internal forces are balanced to external force. Okay, na? Then only we are going to read the stress. Okay. So that's why, please listen. Suppose y, yes, F is nothing but what? F is nothing but what? Restoring force, internal force, otherwise what? External force, whatever may be that one number. That is, please. 1 minute. Over. Okay. So F is nothing but what, Amma? External applied force. Means that is also equal to what? Restoring force only. Otherwise what? Deforming force only. Other same only. Means in the question they will say, are 10 Newton force applied on the block on the area of 10 meter per second square. Then stress is equal to, sir, stress means restoring force only now, sir. Yes, stress means restoring force by area of cross section only. But in this case, means when you are calculating stress, at that case, restoring force was nothing but what? External force. Okay, na? External force applied, Amma. Applied. A is nothing but what? Area of cross section. Area of cross section where the external force is applied, amma. Okay, see here, like this, it's there. This is also area only. This is also area. This is also area. This is also area. But where we are, suppose I am applying force like this means this area only I have to take. Suppose I applied force here means this area you have to take. Okay, now where we are applying, that is important. Okay, by practicing we get amma. Amma, this time, okay, according to Kanishka suggestion, what we are doing means maximum means formulas first I will give. You people have to read. Then after we will practice the questions also. Okay, na Tali Kanishka? Ah, that girl, no response. I don't know why. Okay, yes. Okay. Last section. Okay, fine, fine. Next. Actually, stresses are there are three types of stress are there. Okay. Stress is what? Three types. Write down. Stress is there are three types of stresses. Otherwise, okay, stress is three types. Three types. Okay. One is longitudinal stress. Longitudinal. Second one is tangential stress. Third one is bulk stress. But just 1 minute, Amma. I will come in 2 to 3 minutes, Amma, please. One of the parent is waiting. I have to talk. Please. Amma, please maintain silence and just do the work. 2 to 3 minutes. Just I have to give the information. I'll come. Stress or strain? Stress only, I think. Stress only, na? Yeah, longitudinal stress, tangential stress, and what is that? Fine, bulk stress. Okay, listen. Actually, longitudinal stress is nothing but what? If the restoring force, types of stresses. Wait, let me write. Types of stresses. One is what? Longitudinal. Second one is what? Tangential or shear stress. Both are same only. Bulk or volume. Okay. The tangential. Ah, means longitudinal is one dimensional. Tangential is what? Two dimensions means what? With area, that is nothing but what? Shared stress, sharing stress. And third one is what we have to call, that is, sorry, bulk stress. Nothing but what? Volumetric stress. Otherwise, volume stress. Volume stress. Like that, three types of stresses we discuss. Now, actually, longitudinal stress. What is that? Longitudinal stress means along the length. Suppose we applied. Suppose we applied means what will happen? You have to see. Longitudinal stress means if the restoring force, okay, restoring force means what we applied, that only, suppose we applied means that is only developed into internal forces, that only restoring force also. Okay, if the restoring force are perpendicular to the area of cross section and are along the length on the wire, along the length, so what we applied, it affects the length means, okay, that is nothing but what? The stress is called longitudinal stress. During the longitudinal stress, the body undergoes change in what? Length, amma. Okay. During this, what is that? Length only will changes. In case of longitudinal stress, length will changes. Due to this, amma, please, length will change. That's why I said what? One dimension I said now. So during tangential, area will change. Volume is change. Volume will change. Okay, na? Okay, na? Means what? Size, shape, volume. Okay. Will change some. In what case? Bulk modulus. Okay. Okay, fine. Now, so finally, stress means three types of stresses we discussed. Okay, fine. Now, strain also will be there. Okay. Actually, longitudinal stress formula. What is that? What we have to call? Strain formula. How to do means just see. If you will strain also, I will tell Amma. Then side by side, I will try to give. Okay, otherwise, wait, no problem. Longitudinal stress. Stress is nothing but what? Force by. We applied na some area. Means based upon that only. Otherwise, what? Actually, due to this, in length will change some. Means strain will down. Wait. Tangential stress means due to this tangential stress, what will change some? Area is going to be changes. Bulk stress, due to bulk stress, volume stress means in volume it will change some. So strain means nothing but what? Deformation. The deformation produced per unit area, unit magnitude actually is called strain. Means what? Change in length by length. Wait. Change in length by length. Change in area by area. Change in volume by volume. Those all are change in radius by radius. Means what? Radius is changing means nothing but what, amma? Sharing stress only, na? Sharing stress only or not? Sharing stress means nothing but what? Tangential. See how it will be means see once. Suppose just I applied, amma. Initially this length will be what? L. Please. L. Now because of this force, external force, it is okay. The height is compressed. Okay, this much. See, don't come. Then what is this now? Change means here to here, what we have to call? Change in length only. Na? So strain is equals to change in length by L. Stress is equal to what, amma? F by area. Okay. What is the force we are applied and what is this? Area of cross section. F by area is stress. Strain is nothing but what? L delta L by L. Please, Amma, everything. Suppose it brings the change in area, then shearing stress means what? Delta A by A. Bulk stress is nothing but what? Bulk strain is nothing but what? Strain. Delta V by V. Okay, okay or not? Now listen, Amma. Do one thing. Next, strain. Write down. Strain. Then side by side, I will give the formula. It's better. Again and again means it's a little bit difficult now. Strain. Strain. The deformation produced per unit magnitude. The deformation produced. The deformation produced. The deformation produced. The deformation produced per unit magnitude is called strain. Is called what? Strain. Listen, Amana. The same strains also. How many strains are there? There are three types of strains. Right? I'm same. There are three types of strains. One is what? Transverse or longitudinal. That only. Longitudinal means what? Transverse. Okay, sorry. Transverse only right now. Transverse, sharing, bulk, and also longitudinal also. Longitudinal. Longitudinal, there are three types we wrote now. One is what? Stress. How to write? Stress first one, what you wrote? Longitudinal stress we wrote. Then here also write down longitudinal strain. Longitudinal strain. The second one, what is that? Shear stress. One transverse. What we said about? Tangential strain. Tangential strain. Otherwise, nothing but what, Amma? In bracket, what you have to write? Shear stress. Sharing strain. STR, I forgot, Amma. Strain. R, stain we are writing. Strain, sorry. No mistake. Bulk strain. Strain, volume. Same, both are just like same one, just formulas only. Changes. So now, so actually, tangential over now. Next here, transverse also, please. Fourth one, transverse. Longitudinal, transverse, both. Not tangential, this is transverse. Transverse strain. Okay, please. Means what? Along the radius. Along the radius. This is. Okay. Like this. Strains we got now. Write the formula. Stress to strain. Longitudinal, transverse, bulk I am going to give. Yeah, please. Check. So please ask me, please try to take them. Figures, maybe questions, they're giving that. F we are applying here. What is the height? Suppose h height you can take. Okay, then it is compressed up to here. Means what is this delta h? Here, internal forces are going to be developed. So, nothing but what? So, stress, simply normal stress you can, because perpendicular to the surface, and that's the longitude, your normal stress is equals to, what is the force applied, Amma? What is the force we are applied? Tell me. F. What is the area of cross section? Area of cross section A you can take. Area. Area. A. Okay, area of cross section is what? A. Next, strain. Normal strain. Are what is the change in length? What is the length change came Amma here? Delta H by initial length. What is that? H. We took. Mom, normal means what? Longitudinal means first one. Okay, along the length. Next, suppose second case. See, force we applied here. The same force we are applying, see Amma. Here, like this we are applying. See, on textbook we are pressing like this, means what will come, Amma? Am I right or not? It will come or not like this. It comes like this or not. Just you apply along the paper. Just apply it. So here, what is that? Theta. This is nothing but what? Theta. So along this, what is the means? Some length. Okay. It means what we have. It displaces from here to here. X. Okay. Now some F force only we are applying here. Tangentially. Tangentially we are applying, Amma. So, shear stress or tangential stress? Shear stress. Amma, what is the force we are applying, Amma? What is the force we are applying, Amma? F divided by, what is the area of cross section? Simply this area. A, on A only, like this. Amma, like this, Amma. So, on this area A only. So, A. Okay. Strain means shear strain. Shear strain. Shear strain is equal to, what is the change came Amma here along the tangential surface? They given something. What is that? X divided by what is the height? This is height h. X by h. See Amma, like this they will give the questions. Okay. So 10 Newton. That's why just now the girl asked the applications means like this only. That's why I try to give. Next, bulk. Bulk modulus. Otherwise, what? Volume. 1 minute. Suppose volume means what? Sphere you can take. Okay, sphere. Like this in all directions I am applying. Means to compress and whatever maybe I am applying force like this, means what will happen somehow? It is going to be compressed. So up to this much, okay, up to this level, okay, this much is going to be reduced. Then after what will happen? Internal forces are going to be developed now here inside. That's why, please. Stress is equal to, what will happen? Pressure exerted. Am I right or not? Pressure will exert or not? So in what direction? Opposite direction. What is that? That one only how to do it. That's it. So volume of applied gas is reduced by the external pressure. Volume of liquid or gas is reduced by external pressure. So that's why volume stress or bulk stress. Bulk stress. Ma pressure, okay. Stress both are same means no. Pressure means always perpendicular to the surface only. Thrust force only produces the pressure, amma. Thrust force only. Thrust force means nothing but what? Normal force. Okay. Bulk stress is equal to what? Write down. Bulk stress or volume stress also you can write down. Volume of liquid. Otherwise, okay, write the expression later in bracket. You can write pressure exerted. External, otherwise external simply. Okay, here you write down. Here you write down. Here you write down. Ma, stress also again. I forgot. Ma, please compulsory remind me. What is the nature of stress means? What is tensor, ma? Again, I forgot. Write down. Back. Stress. Unit you wrote, na? Unit you wrote somewhere. Newton per meter square. There only write down. Nature of stress is tensor, not vector, not scalar. It is a tensor quantity, ma. Again, I forgot. That's why. Please write down. Stress is a tensor quantity. Write down. Volume of liquid or gas is volume of liquid or gas. A gas is reduced by is like this atmospheric pressure. Pressure, water may be the pressure. That atmospheric pressure or something, leave it. They didn't mention. Pressure means what? Force by area of cross section actually. Sir, how we can take, sir, means listen. This is center, amma. Each and every force will be what? Perpendicular to center only in a normal. See, this is what? Every tangent will be what? Perpendicular only, na? Curvature, along the radius of curvature, amma. Radius of curvature is perpendicular to what? Means normal is perpendicular radius of curvature. Maybe people will know some. Fine, listen. Volume of liquid or gas is reduced by pressure right, that's it. External number. Next, strain, bulk strain or volume strain, both are same only. Strain is equal to what? Change in volume by initial volume. Change in volume by initial volume V. Okay. Okay, fine. Like this means okay, means next different cases, listen. Copy it. But tangential is there, not tangential is there, but what? Delta, okay, at last we will write limit. Delta R by R only is along the radius in between. You want to write this right up, no problem. Transverse strain is equal to delta R by R, means in radius it's going to be changed. At last we will write, no problem. Next, please, few more applications like this will apply now. Fine. So I'm going to take. So now I'm going to take this with this. Okay. Fine. Okay, please. Write down applications. What are the applications we are going to see? Applications, amma. Okay, please. First example, otherwise water maybe you can say, no problem. Like this one block is there, amma. I applied force like this means happily you can. What is the F by A you wrote? But I applied like this. F force. F force I applied like this. Then what will happen, amma? And it makes some angle theta, amma, with this. Now just resolve it first thing. How to resolve or not? That means see these only applications. F, okay, this is theta, means this is also theta. F cos theta acts like this, and the F sin theta will be acts like this. Am I right? Am I right or not? Like this, it makes angle with this, So this is nothing but just resolve it. F cos theta, and this one is what? F sin theta. Am I right or not? It's clear or not? Amma? Yes. So what we can write? Simply F sin theta we can apply. F cos theta we have to apply here. Am I right? Am I right or not? For the same diagram I can redraw like this. Okay. Amma Babu, what happened, Amma? Okay or not? Tell me, no problem. So what will happen means, see, due to F sin theta, it's going to be compressed. Delta H. Due to F cos theta, it went towards hysteresis X like this. Am I right? Am I right or not? See, what will happen? F cos theta will be acts like this means the final figure will be what? Like this for this. Okay, due to this one, it maintains what? Delta H. Height compression means height change will come or not. So because of this one, what? Normal stress. Because of this one is what? Tangential stress. Am I right or not? Because it inclined like this. That's why. So you have to resolve like this and like this now. Hello, it's clear or not? Like this only questions will come some. Please, you didn't get me, it's no problem. Please tell to me. Suppose 2 root 2 Newton force I applied like this. It makes suppose 45 degrees. So 2 root 2, this is theta means this is also theta only. Cos 45 1 by root 2 into 1 by root 2. And this one is what? 2 root 2 into 1 by root sin 45 also. 2 Newton. 2 Newton will be acts like this and 2 Newton will have to like this. Am I right or not? Ma, please tell me, no problem. Okay na? Okay or not? Okay. Ma, means I won't means numerical just F like that only I will try to. Ma. Anyhow, I will give again. I will send one. What is that notes? Short notes and written notes also key points. We are going to send them. Okay. So please next what we can write for this normal strain is equal to what is that? Normal strain is equal to what you can write, Amma? Tell me. F sin theta, strain or stress? Strain or stress? Strain only we are talking about. So perpendicular by area of cross section. F sin theta by A. Next, normal stress. Sorry, tan. This is normal. What we have to call? Shear stress. Shear strain. Shear strain. I'm confusing the pain. Sorry, names. Shear. SHEAR. Shear strain is equals to what once again? F cos theta by F cos theta by A. Okay na? Okay na? Now, ma, I have to, sorry, what I wrote stress na? F by A means, sorry, that one. Why like this? Stress only I said, sorry, I'm confused. Not confused. Something. I'm thinking of for morning batch electricity, for evening batch viscosity, for you people, something. There, here to here to there, here to there to here. I'm going to be collapsing. Okay, please. Wait, let me arrange. Stress sum. Please write down. Write down. Please copy it. It's clear or not for you people? It's clear or not? It's clear or not? Oh, it's not clear means please tell me. That's it. Fast. Ma, Amma, I can't hear. Ah, what happened, Amma? Okay. Next, completed. Write down. What is that? Bulk strain also, Amma, please. Not bulk strain. Transverse strain. Transverse strain is equal to transverse strain is equals to change in radius by original radius. Change in transverse strain is equal to change in radius by radius. Radius is equal to what? Delta R by R. Delta R by R. So next. Ma, sair strain means okay. People wrote na see. Board erased. My board erased. No, so people have to means what we wrote. See displacement. What is some x we took na? H. What is this H? Ma? Height means what? The gap between these two layers. The gap between these two layers. Okay, these two layers, Amma. They already it's there. I gave, but even though, please. Okay, fine. Next. Listen, Amma. Now, elasticity. Next, elasticity is nothing but what, Amma? Simple direct formula, Amma. What is meant by elasticity? It is nothing but what? Simply, actually, Young's modulus will come stress by strain. Stress by strain is equal to what? Elastic modulus, the modulus of elasticity, Amma. So after that, Young's modulus will come longitudinal stress by longitudinal strain, Amma. After that, thermal force will comes. Okay, thermal force will comes. So first thing, elasticity. Right now, elasticity. Board. On whiteboard when I am writing, please write. Elasticity. Hooke's law, do you know Hooke's law? Anybody can? Hooke's law. Yeah, very famous Amma Hooke's law. You don't know means I have to scold for you. Hooke's law. Hooke's law ra bhai. Ohm's law, Hooke's law, okay, gravitation law, inverse law, those things people don't know means I have to scold you people. Okay, write down. Within the elastic limit, write down. Within the elastic limit, stress is directly proportional to strain. Stress is cause, Amma. Strain is what? Effect of. Stress is directly proportional to strain. So stress is equal to what we can write with some constant we have to introduce. What is that? E. Modulus of elasticity. What we have to call E? modulus of elasticity. So E is equal to stress by strain. Please cut box, keep it. Stress by strain, elasticity. Next. Next. It is equal to constant amount, please. E is nothing but what? Modulus of elasticity. Modulus of elasticity. Next. Young's modulus. Young's modulus. Babu. Yes, someone called. What is that? But please. Ma, what is the unit? Ma, sorry. Units people have to write now. Units people have to write or not? So stress by strain. So simply order method unit in SI system. SI system. Ma, units. Down you write down. SI system. Stress by strain. Okay, actually these all are what. Finally you get what F by. Listen. F by A by change in length by what is that length. Okay. Finally what we will get. So this one meter square. So Newton per meter square by change in length also meter. This is also meter only. So meter you can neglect means what is that Newton per meter square only. Na? So Newton per meter square modulus of elasticity. SI unit is what? Newton per meter square. CGS unit is nothing but what? CGS unit is nothing but what? 10 per centimeter square. 9 per centimeter square. Next, please. Young's modulus. Next word. Young's modulus. Young's modulus. Why? Young's modulus is nothing but what, Amma? Write down. Longitudinal stress by longitudinal strain. That's it. The ratio of longitudinal stress by longitudinal strain. Array, this is longitudinal stress means what? F by A by longitudinal strain means what? Delta L by L only, na? So simply what we can write, please? Simply what we can write? This L means FL by A delta L. Am I right or not? Am I right or not? Come on, C and L. That only, na? That only or not? So, fine. Right. Oh, suppose now, if M load I am applying, Amma. Okay, listen. This is the string, Amma. M load, please. Kanishta. M load I apply. Okay, so what is the external force acting here on the rope here? mg only, na? mg only or not? So F is equal to what? mg. So here to here, okay, that rope is going to be extend this much. Delta L. Change in length. Okay, initial length will be what? L. Listen. Now, Young's modulus is equal to what? Sorry, y is equal to what? Young's modulus. In place of F, what you have to write? mg, initial length L, area of cross section. That is important. What is the area of cross section here? If the string radius, okay, string radius like this is there, r radius they given, okay, pi r square only na talli. Pi r square, this area is nothing but what? R radius means circle, just like circle only now. Pi r square. Pi r square into expansion. Change in length is nothing but what? Delta L. Otherwise, E also you can take. That's it. Y is equal to what? You got it or not? You understood or not? Tell me, no problem. Tell me. So write down. If load is M, otherwise, please, wait. A diagram picture I will draw. Wait, it's better. Cut down. Wait, neatly I will. Why? Because this is only the notes for you people, finally. Formulas, every means, generally people have to read this notes. So what we are doing, M load we are applying. M load we applied. One more line I will draw. Very good. Oh, fine. Now I applied some force at down. Some load or force, whatever maybe that one. Yeah, force I applied. It's clear or not? Yeah, weight. Okay. F okay, is equal to what? mg load. Okay, here what? Load. I applied load. M massive load. F is equal to what? mg. Otherwise what? mg. mg will be acts vertically downwards only now. mg acts vertical downwards only or not? So now stress is equals to area. See this area means here that one just okay like this they given okay F. So radius r is there. So area A is equal to what? Pi r square only now. Ma for circle just like a month. So imagine like this they given. So what is the area of cross section for this one? Area of cross section is equal to pi r square only or not? Arey. Sriram, okay na Ramya, okay na Shubhleka, okay or not? Tell me. It's not clear means no problem. I will once again. Ramya Shubhleka Sriram Harini Tarun. Ah? Okay, fine. Please copy it there. Take a diagram. Next. If load is M, if load is M, then F is equal to mg. Y is equal to what is that, Amma? Please come on, tell me. mg L by area, what we can write? Pi r square into delta L. If delta L you are taking, E means expansion. Okay. FL by A into E also you can write. E is equal to what? Delta L. Okay. That is equal to what means? Your wish. Pi r square E. Hey, school time on Dinesh Velale. Idiot. వద్దా అమ్మో టీచర్ కొడతారు టీచర్ కొడేస్తారు తినప్పుడు బ్యాడ్ బాయ్ అయిపోతావు చాలా బ్యాడ్ చాలా బ్యాడ్ అరే కూర్చోరా ఆపు తినేవాలి తినే స్కూల్కి వెళ్ళాలి ఎక్కడికి వెళ్తావు ఆడుకుంది కానీ ఓకేనా అరే ఆపురా నీ క్వశ్చన్స్ I'm not in mute. You're fine. R is nothing but what, Amma? Where R is right on. Where R is radius of wire. Radius of wire. L is length of the wire. E is expansion or change in length. Change in length or expansion of wire. Okay, na? E or delta L, both are same only, Amma. Expansion, simply. Please start. But stay, y is what? Y is what? Young's modulus. Okay, now please. I didn't write that one. Next. Now, if stress required to double the length of a wire or what to produce 100% longitudinal strain is equals to Young's modulus of the wire. Okay. Next, y of perfectly elastic material is infinity, means Young's modulus. Okay. The perfectly inelastic bodies, y is equal to what? 0. These are all things we are writing here now. Listen. For y, Young's modulus for perfectly elastic. Perfectly. Perfectly, I forgot. Perfect CTLY only, na? Perfect elastic bodies. Elastic. Perfectly elastic bodies. Infinity, amma. Imperfect. Perfectly inelastic. Perfectly inelastic. Perfectly inelastic. Elastic is equal to 0. Star mark. Next. If load M produces an elongation, suppose expansion EM, suppose for example, in a wire, the raise in temperature required to produce the same elongation is nothing but what? How to means, listen. Elongation is nothing but what? Alpha into delta T only, na? Phi line E is equal to, change in length is equal to what? Means thermal alpha is equal to what we learned. L2 is equal to, okay, final expansion. E is equal to, otherwise, initial change in length by initial length into change in temperature. Am I right or not? Change in length is nothing but what? Elongation, otherwise what? Expansion only. No? Final minus initial expansion by L1 into delta T. So, expansion E is equal to what we can write? Alpha into L1 into delta T. Okay, please keep it in mind. Wait. Now, that means what? Expansion you got. Now, so Young's modulus is equal to what we wrote, Amma? Young's modulus is equal to what we wrote in previous board. See, mgl by pi r square into E. Pi r square into E. We wrote that one only now. So here F is nothing but what? F is nothing but what? Otherwise, mg is equal to what? Y into pi r square is nothing but what? Area only now. Pi r square is nothing but what? Area only or not? Listen. Mg is equal just here cross multiplication. This is nothing but what? Mg L by AE only na. Please wait. A means simplification form. I am writing, that's it. AE, that's it. By Mg into L is there. That L will comes down. That L will comes down now. So by L. Okay. Now my Mg is equal to what we can write actually here. Suppose in case of thermal force we are doing means mg is equal to y a elongation expression C1 we wrote it. What is that? Elongation alpha into L1 by delta T. Am I right? Am I right or not? Am I right or not, Amma? Wait, final result only people will write. Let me derive first of all. Why these all things for you people? See what I wrote. YAE by L. Please tell me. YAE by Y. Mg is equal to what? YAE by initial length means what? L1. Okay now. initial length L1 I took. Now, just here, what we know is mg initial length L1 by what I wrote here, mgl by. We wrote now one formula. Please come and tell me. mgl by AE only now. AE. Am I right? From here also, E is equal to what we can write. E is equal to what we can write. Just in place of this one. Okay, E by L1. E by L1 is there or not here? E by L1 is there or not? Alpha into E by L1 is equal to alpha into delta T only na babu. Am I right or not? So here we can write or not, check it. We can write or not. L by E1 means what? L by E1 means nothing but what? Come on, substitute. L by E1. Array 1 by alpha delta T. That's it. So alpha delta T. So simply mg is equal to what we can write? Ya alpha delta T. It's clear or not? Directly we can write or not? Directly, wait, I will give point wise sum. No problem, just wait. You people got it or not? Simply I linked, means thermal and expansion. Write down now. If, point wise, if, next point, if a load M produces an elongation E in a Y, a load M produces an elongation E in a Y, comma, the temperature, the rise in temperature required to the rise in temperature required to produce the same elongation is delta T. Then Y is equal to mg is equal to Ya alpha delta T. Where delta T is what? Change in temperature. E is what? Elongation. Or what? Change in temperature, change in length. Anything. Change in length. Okay. That's it. A is what? Area of wire. Area of cross section of wire. Area of wire. Okay now. Okay or not? Next. Alpha is nothing but what? Coefficient of linear expansion. So over or not? Alpha is coefficient of linear expansion. Next term, please, the same like this between two rigid walls, a wire. I kept a rod like this. This is what rod, fixed walls. Fixed wall. Listen. Now I am giving heat energy. Here. I am giving heat energy. Then what will happen? It will tries to expand this one like this and like this also. But it won't. This is fixed walls now. So in opposite direction, to restrict this one, this expansion, thermal force is required or not? Thermal force will be there. Then what is the thermal force they are asking? What is the thermal force? Simply in place of mg, just you keep what F. That's it. Write down. Please keep the diagram first thing. Please, my rod like this. Young's mod. Please keep the means diagram like this. Y is the Young's modulus. Y is the Young's modulus. Area of cross section is A. Thermal expansion is what? Alpha. Change in temperature delta T. Same. Okay, a metal bar. This is what a metal bar. Metal bar. Metal bar. Right down. A metal bar. A metal bar is fixed between two walls. A metal bar fixed between two walls. Two walls has a rise in temperature. Has a rise in temperature. Has rise in temperature. The bar tries to expand. The bar tries to expand and exerts force on the wall. On the wall. Exert force on the wall. Amma, once again. Shall I? Okay. When a metal bar is fixed between two walls, my diagram is not nice, means again I will draw, no problem. Between two walls has a rise in temperature, the bar tries to expand, and exerts force. Amma, what happened, Kanishka? Shall I again? Anyway, you forgot right or what? And exerts force on the walls. This force is called, write down, this force is called thermal force. This force is called thermal force. Diagram okay na for you people? F is equal to YA alpha delta T. That's it. Where F is what? Thermal force. Okay. Thermal force. Delta T what? Change, rise in temperature. Rise in temperature. That's it. Actually, thermal force is independent of length of the bar. Metallic bar, ray. Bar means people will think something. Metallic bar. Okay. Now, a thermal force you got, then write down next point. Thermal stress. Easily you can. Thermal stress. Force by area. Thermal force by area. Thermal force by area. Thermal force, what you got, by YA alpha delta T by A. A going to cancel means Y alpha delta T. That's it. Thermal stress. Y alpha delta T. Actual thermal stress is independent of what? Area. Thermal stress is, right on. Thermal force is independent of what? Length. Thermal stress is independent of what? Area. Right on. Thermal stress is independent of what? Area. Now, elongation due to its own weight also we are going to do, Amma. Elongation due to its own weight. Okay. What's time now? What's time now? Almost 12:30, yeah? Yeah. Okay, from that point onwards, next I'll continue, no, please. Okay, we can, what we have to call, we have to eat something, na? Sapad. Kudu. Sapad kudu, everyone. Okay, please. Take, uh, take your lunch. Again, any possibilities there, evening I will try to take, otherwise tomorrow only. Satish sir came or not? Satish sir came or not? So enjoy with Satish sir next. Fine. I come on within soon. Satish sir means very near to you people. He was, I think, so he was in abroad only. But I am very far now. Almost border of the India. Visakhapatnam. Do you know Visakhapatnam? I am from Vizag. Okay, fine, fine. Just okay. I will come on within soon. I will come. Fine, fine. Please. Thank you. Thank you. Thank you. Bye, bye.